So for part 3 of Module 2, we're going to look once again at output, more specifically the final results and the stress and the utilization, how you can visualize those in Crumba, and then take that into Rhino. So something we added in the very first module but never really talked about was the results and outputs, model view and beam view more specifically. So when you open it, it usually comes in these sort of packaged setups, and if you click each of these subtitles, you're given a lot more options. And what these options are, the most useful ones are the scales. So deformation scale doesn't change the actual deformation of the beam, but it changes how we view it. And so if I double click on the white dot and I set it to 1, that's what the real deflection is supposed to look like with the loads that we chose and the supports that we chose and the beam member size that we chose. That's how much it would deflect roughly in real life. So I can exaggerate it more just so I can really drive home the point that it's bending. And you can change things like that. You can change the support sizes, you can change the load sizes. None of this actually changes the analyze or the actual numbers. It just changes what you see. And why that's useful is when we're going to get to the point where you can export this stuff into Rhino so that you could print the results and measure them yourself if you want to. These scales are very important to keep track of, so you know if you're looking at the real results or something that's exaggerated. The next important thing is the structure tags. And as we were talking about in the last part of Module 2, every element has a name or a number more specifically. So in the deflection calculations, we found that member 2 had the maximum deflection. And if you look at it, after turning on the structure tag element tag, member 2 is the one in the middle, which obviously is deforming the most out of all of them because it's sinking straight in the middle. And you can also turn on material names. Currently they're all a default material. You can turn on the load values. We're applying 1 unit of whatever load unit there is. And more options like that. The node tags, which does the same thing as the point list command. You can see 0.1, 0.1, those are the same node, 5 and 5. So that proves that command works properly. So in beam view, what's helpful is the render settings. So right now I have it set on axial stress, and what's that showing me is the stress within each of these members. And we just have a bunch of colors, but we don't really know what that means. And so what you want to do is go to the display tab in Grasshopper and click on graphs and legend and drag that out. And if you connect the C and the T, you're given basically a scale legend that goes from red to blue, showing the tension faces and the compression faces and what values they are. So now the colors actually have some legibility to them. They tell you the darkest color is 1.13 times 10 to the 1, so 11.3 kilonewtons per centimeter squared. That's the stress of the dark blue versus negative of that on the dark red. And so that's the useful thing out of that. So now that you have all of that, you want to take this into Rhino so that you could print your results. So if you right click on beam view and click bake, and then you can choose a layer. I'm just going to set it on the default layer. Now what I've done is export this stuff into Rhino. So if I turn off all of the Rhino stuff, you can see, turn off all the Grasshopper stuff, you can see that this stuff is now in Rhino. So if I select it all and move it all over, I haven't actually done anything. All I have here, so if I view it in shaded view, I just have a bunch of polygons that represent the geometry. And then if I view it in rendered, you can see that the colors come back into play, and you can see the stresses in the rendered view, which is really useful for when you want to export this information to another format. And that concludes Module 2. I hope that was helpful. If you have any comments, please let me know. Thanks. Bye.